Across the country, Americans are feeling the impacts of a changing climate. 2024 brought the hottest summer on record, beating out 2023. The abnormally warm water temperatures in the Atlantic fueled rapidly intensifying, highly destructive storms like Beryl on the Gulf Coast and Helene over the Southeast. Those climate events alone cost upwards of $60 billion in economic losses for the United States. Meanwhile, we're taking some steps to reduce the emissions that contribute to climate change and its consequences. In an executive order signed in January 2021, President Biden set a target of 100% clean electricity. The 2022 Inflation Reduction Act, the IRA, expanded incentives in the United States for a broad array of clean energy resources like wind, solar, and storage facilities. Proposals for these renewable energy projects have surged, and yet, despite growing electricity demand, many of the projects have yet to get off the ground. Here to explain why and how we can accelerate the shift to clean energy is Daniel Cohan, a professor of civil and environmental engineering at Rice University and a Baker Institute faculty scholar. I'm David Satterfield, director of Rice University's Baker Institute for Public Policy in Houston, Texas, and this is Baker Briefing. Dan, thank you for joining me today. Let's start with the current energy landscape in the United States. We know it's accepted that use of fossil fuels is causing harm to the environment, but we very much remain dependent on fossil fuels to meet the majority of our energy needs. So what percent today of our energy supply nationwide is powered by fossil fuels? What percent comes from clean energy sources? And if you could just define again quickly for the audience, what constitutes clean energy?
Yeah, thank you for having me. And if we think about energy use in the United States overall, we've been stuck at a level that about 80% of all energy use continues to be coming from fossil fuels, just like it has for decades. And that's opposed to cleaner or low emitting sources such as nuclear, biofuels, and wind, water, and solar power. When it comes to electricity and Biden's target for 100% clean electricity by 2035, there the shift has been happening more quickly. We've been having a shift from fossil fuels to cleaner options. Fossil fuels remain the majority of our electricity generation, but we're seeing many regions of the country where solar and wind are providing rapidly growing shares of the electricity supply.
If you could just give us a breakdown over the last 10, 20 years, whatever a reasonable time frame is, for electricity generation in the United States, use of coal, oil, gas, clean energy sources, non-fossil fuel. How does it break down? What are the trend lines?
Yeah, so we stopped using oil substantially for electricity a long time ago. It's just too expensive to use for that purpose. But for a long time, coal was our leading source of electricity. And in fact, the government pushed for coal to be our leading source of electricity because after the Arab oil embargoes, there was fear of shortages of oil and natural gas. Over time, we had a shift from coal to natural gas to the point that now natural gas is our leading source of electricity. In the mix with that, we've long had hydroelectric dams that provide important sources of power in part of the country, but we've really stopped building those for many decades. And we have about 100 nuclear reactors left, but we've been closing them faster than we've been adding them. Just this year, we had the first 2 new nuclear reactors built since I was a toddler. So it's really been since 3 Mile Island in the 1970s that we haven't been building much nuclear. And so where the rapid growth is happening is in wind and solar. And those started out 15 years ago from being minuscule shares of the electricity supply to the point where the vast majority of the growth, in some years more than 90% of the growth in electricity supply recently has been coming from wind and solar power.
And Dan, I'm going to come back to wind and solar in a moment to touch on the issue of storage, deliverability, peak hours, off hours. But before I do, the Environmental Protection Agency under this administration has established rules to cut pollution from existing coal plants and new natural gas plants. What's the impact of this on the ability to generate power to meet electricity demand?
The impact of these EPA rules could be enormous if they're allowed to hold as they go through court litigation, because they are final EPA rules, but they're being contested by some Republican state attorney generals. But if they go forward, then the rules on coal would essentially mean the end of coal power generation in this country by the mid to late 2030s, because essentially they only allow coal power plants to continue generating power if they've got a retirement date in the late 2030s, or if they install carbon capture to capture 90% of their CO2 emissions. And there is not a coal power plant in the country that gets anywhere close to capturing 90%
And just quickly,
of
Dan,
emissions.
as we focus on the impact of these regulations, what percent of electricity in the United States now is generated from coal?
So right now, coal supplies 16% of the electricity supply in the United States. And if these EPA rules survive court challenges, then virtually all of that coal electricity will need to close by around 2038, because the rules require 90% carbon dioxide capture from any coal plants that want to stay operating into the late 2030s. And no such plant exists today. Here near Houston, we have one plant that does capture a much smaller portion of the carbon dioxide from one of its units, but we haven't seen 90% capture at a commercial scale anywhere in the world. So this would essentially put most coal plants out of business, because it would be far too costly and far too energy intensive to run the carbon capture devices. So these rules would basically be the end of
But
coal
Dan,
power.
aren't we on, and correct me if this is not correct, a progressive downward trend to near zero in terms of coal as an energy generating source in any case?
Right. Much of the downward trend in coal has already happened, is ongoing. A huge portion of coal plants have already scheduled retirement dates because most of them are losing money or barely breaking even. And because wind and solar have gotten so affordable that in many cases, it is cheaper to add wind and solar where needed, backed up by batteries, than to run existing coal plants. Even coal plants that have already paid for the cost of building themselves can be more expensive than wind and solar are today. So this trend is happening, and the EPA rules would just put the final nail in the coffin and really be the final end to almost all coal plants in the country.
What factors are driving growth in demand for electricity? And is that growth uniform across the United States?
We're hitting an inflection point with electricity demand in that for decades after World War II, as the economy was growing fast and we had the baby boom, electricity demand was growing 5 to 10% per year. And then we hit a period in the early 2000s when electricity was a really stagnant, boring industry, when demand nearly flatlined because efficiency was growing fast enough to keep pace with economic growth. We had LED lights, we had more efficient air conditioners, more efficient appliances. They were basically keeping pace with each other, and we didn't have much growth in demand. Now we're hitting a point where, because we see more data centers, more artificial intelligence, more electric cars, and electrification of heat in certain industrial processes, all of that is starting to create growth in electricity demand again, where we're starting to see 2 or 3% per year growth. It's not as dramatic as some of the headlines are saying. Even as data centers and artificial intelligence are growing, they remain a small share of the overall demand. But these trends of various forms are leading to this inflection of having a bit of growth in electricity demand again.
Growth of the clean electricity sector, requirements to promote clean electricity. One of the problems, and I know Texas is a model for this, is extensive development in recent years of, for example, solar and wind. I believe Texas just overtook California as the leading gigawatt generated from solar power in the United States. But battery storage capacity, technologies, and the ability to deliver solar or wind generated electricity at the times in the market daily demand when they're needed remains a significant problem. So how is engineering, how is technology doing to catch up on storage and delivery to make this peak demand, low demand imbalance work out?
Storage technologies have been improving in quality and plummeting in cost at an astounding pace. The cost of lithium-ion batteries, which is the main way that we do storage of 1 to 4 hours, have been plummeting at similar curves to what we've seen for solar panels. Solar panels over the past 10 to 15 years have fallen by more than 90% in cost. And we're seeing battery costs plunge in similar ways to the point that using batteries in combination with wind and solar is now sort of a winning pattern for, in many cases, providing the least cost combination of round-the-clock electricity that we can get in many regions.
How's Texas doing on that specific challenge?
Yeah, so Texas has long been a leader in wind power, but we were pretty slow to the game when it came to solar, and battery storage nationwide wasn't a big player until very recently. Now we've seen Texas add solar faster than any state has in history, and we've seen battery storage growth nearly as fast as what's happening in California. So all three of those sources, wind, solar, and batteries, have been growing tremendously fast, and they've been game changers in terms of some summer heat waves recently where we would have likely had rolling blackouts if not for the wind, solar, and storage that have been added to the grid just in the past few years.
So, Dan, if the stakes are so high, if technologies are improving to the point of economic efficiencies in delivery of appropriate supplies of power, clean energy-derived power, at critical times, why haven't clean energy projects been able to move forward more rapidly? What's the issue? Why do fossil fuels, even with the shift from coal to gas, still constitute the bulk of power generation?
The technologies are there and they're affordable, and developers want to build these projects, but they're facing tremendous bottlenecks, sometimes called queues of lines of projects waiting to be built, and very slow processes to get them connected. And what that comes down to is, to a certain extent, gaps in the amount of transmission capacity we have, but also it comes down to bureaucracy and needlessly complicated studies and modeling and red tape and approvals that in many cases stretch for years and push the time to get a wind or battery storage or solar project built in the United States to be more than twice as long as it is in parts of the world such as China or India.
Is there resistance from the fossil fuel industry, which has an enormous sunk cost in facilities that utilize fossil fuels for power generation?
It's hard to say exactly where the resistance is coming from. Some of it is coming from local communities opposing new transmission lines or new wind or solar developments or even battery storage developments in their backyards or in their counties. And it's hard to tell how much of that is genuine opposition and how much of it is funded by fossil fuel groups or other special interests. But that is a holdup. Projects are being held up not because of any particular opposition, but because grid managers just aren't equipped with enough staff, with enough resources to get projects approved. Even projects that don't have much opposition are languishing in the queues and not being built fast enough.
All right, Dan, wave your magic bureaucratic wand, and all projects in those queues you spoke of are approved. When built, when operational, what impact would that have on clean energy versus fossil fuel as a percentage of generation?
Building those projects would completely revolutionize the grid. The backlog of projects, wind, solar, and storage, is twice the capacity of the entire electric supply across the United States today. Now, when I say twice, it's not quite an apples to apples comparison because solar and wind don't generate all the time, whereas nuclear plants run the vast majority of the time. But that level of scale shows you that it would completely revolutionize the grid. And neither I nor any expert who looks at the situation thinks it would be possible to build that entire queue, that entire backlog of wind, solar, and storage that is twice the size of our entire grid today. Some of those projects are there counting on some of the other projects not being built. The wind and solar would compete with each other, that it's not realistic to think they would all be built. But what we need is policies that allow bigger shares of that backlog to be built. And as they're built, what we'll see is money losing and marginal coal and inefficient gas plants are likely to retire to make room for these cleaner sources to come online.
All right, Dan, I want to shift to nuclear. There has been a revolutionary development in the nuclear power industry, the so-called small modular reactors, the SMRs. which are just now coming onto the market as commercially feasible proposals. And they range in the theoretical from sources of power that could be used on commercial farms to individual fossil fuel production facilities. They would transform power generation, including at a very micro or sub-micro level throughout the US. What are the challenges to acceptability of SMRs?
SMRs are a real wild card and a real unknown at this point because we don't have any in operation to know exactly how they perform and exactly how much they'll cost. We have some tremendous developments in the past year where some of the biggest tech companies wanting to build data centers and AI are starting to turn to small modular reactors as options for what might power those data centers, perhaps by the early 2030s. But if we look at the projects that are likely to come online by the early 2030s or by 2035, when President Biden wants us to hit 100% clean electricity, we're unlikely to see very much of them come online by then at all. I think in a best case scenario, we might see several gigawatts of them built at first, whereas we're adding many dozens of gigawatts every year of wind and solar. So for the foreseeable future, they're going to be small. And for the foreseeable future, because they don't have the economies of scale, because we don't have as much experience building them as the traditional larger scale nuclear reactors, they're probably actually going to cost more per unit of electricity than the old, boring, traditional nuclear reactors do. And each of those is far, far more expensive than wind or solar. So they offer the potential that if they work out in the pilot scale and we have these huge tech companies bankrolling the initial rollout, that because they're modular, they could have the possibility of hitting the learning curves that we've seen for other resources. And so perhaps by the 2040s, they would fall in cost to where they could be competitive with other sources. But I don't think we can say with any certainty that that will definitely happen. And I think the initial rollouts are really only possible because we have big tech companies willing to spend several times as much for those initial pilot projects as the same amount of power would be from wind, solar, and storage.
Okay. Back to the project queues and the permitting issues you raised. Are those federal permitting or state and local permitting or a combination of all?
I think part of what makes building electricity projects in the United States so complicated is that it involves officials at every level of government, is that you can have objections from county commissioners and local farm and ranch holders. You have state policy that governs what states want to be on the grid. You have federal policies that largely come out of FERC, the Federal Energy Regulatory Commission. And then in between all of these, you have grid operators. As we know in Texas, it's ERCOT, but in other parts of the country, you have different grid managers that have set different policies. And all of those play a role in determining which projects get built. But really the biggest gatekeepers are those entities such as ERCOT, or there's one known as PJM that covers much of the mid-Atlantic part of the country. And ERCOT's actually got one of the fastest paces of approving projects right now. But many like PJM have been extremely slow in approving projects, and projects have been languishing in the queue for 5 or 10 years before, in many cases, just giving up and not being built.
So Dan, you mentioned ERCOT and grid management, both as a Texas issue and nationally. Let's talk just about Texas. There's been much discussion of the grid failures, grid vulnerabilities to a variety of natural phenomena, ranging from ice storms to physical damage to the transmission lines. How is grid resiliency in Texas, and what steps are being taken to improve it?
Yeah, so in many ways, ERCOT is a role model for what should be happening with the interconnection queues. But when it comes to resiliency and the reliability of our grid, ERCOT is a real laggard and has suffered some real black eyes and some real problems in keeping the lights on. And really, there are two types of problems that ERCOT faces. One is what we saw with the blackouts and the winter freeze in 2021, is that by being an isolated grid, by not being able to bring in power from other states when we need it, we have to generate all the power that we need in state. And so when those sources suffer and all of our main sources of power supply struggled during that freeze, there's just little way backup, not much resilience to get the power back on.
And Dan, I will add, it did not help during that freeze to conserve electricity by cutting the power to the compressors that drove natural gas to electricity generating facilities. That was not a grid issue. That was a management issue in a single building in Austin.
Right. The majority of the shortfall we had was because of less natural gas and electricity than we expected, and mix of natural gas power plants that froze and power plants that would have operated just fine, but the supply chain froze up, in part because 3-page documents to make sure that compressors were treated as critical infrastructure and didn't lose their power weren't filled out. So yeah, a lot of needless mistakes, a lot of things that I think have been corrected by legislation and by Public Utility Commission and ERCOT action since then. But yeah, a lot that went wrong during that storm. The majority of the time when we lose power at our homes, it's not because ERCOT statewide doesn't have enough juice to flow around. It's because a tree has fallen on a line, 50-year-old transformer has blown out because some local small-scale issue has happened, and our grid was largely built in the post-World War II decade. It was largely built in the 50s, 60s, and 70s, has a lot of old equipment, a lot of wooden poles and above ground lines, and has often had failures and been very slow to come back online when we've had storms, such as most recently Hurricane Beryl and some very strong wind events, derecho events that happened this year that show how quickly power can go out.
But Dan, this is not a unique phenomenon to Texas. I know in Midwest, in East Coast, West Coast cities and communities, the cost of burying transmission lines is in the many multiples of billions of dollars if the permitting could be obtained to do it. And if from a simple infrastructure standpoint, the road cuts, the physical changes necessary to do those burials could in fact be accomplished. It's a very tough thing to make more resilient a network to a storm like Beryl or equivalent storms that simply bring down the lines, bring down the poles.
Right. It's simply not feasible to think that we're going to completely redo a system that's been built over the past 70 years and completely underground infrastructure that's built above ground for so long. And I think some smart decisions are being made where certain key areas where it does make sense are being undergrounded, and where old poles that are vulnerable to falling down are being replaced, where transformers are being upgraded, where smart equipment is being put in so that the system can more quickly see where there's a failure and reroute power supply around it. So I think investments of more manageable scales are starting to be done that can improve things. They're never going to completely avoid blackouts, but we can reduce them and we can make power supply come back online more quickly, as it does in some other parts of the country and other parts of the world.
Now, Dan, I've got 2 final questions for you. The first is one that has fascinated me for a long while. With the exception of legacy connections to, as I understand it, Louisiana and perhaps Arkansas, Texas does not wheel electricity out or in. It cannot shed load. It cannot gain power from other states in its vicinity. How unique is Texas nationwide in this regard? An entity unto itself?
Unless you count Hawaii or Puerto Rico, ERCOT is completely unique in the continental United States. Yeah, we just have those lines. There's also a slender line down to Mexico, but we are barely at all connected to the 2 main power grids that dominate the continental US, and even up into Canada and Mexico are connected to those 2 grids. There's a Western interconnect and there's an Eastern interconnect, and then there's ERCOT all alone as an island. And there have been many studies saying that the more that we can get connections between those grids, which are challenging because they need to be direct current lines that transfer power between these alternating current grids. But the more of those connections that we can build with ERCOT and the others and between the East and the West, the easier it will be for grid managers to balance a range of variable supply sources into the future.
What's the historic reason for this, and is it changing? Is the mentality changing?
I think the historic reason was wanting to maintain control of the electric grid within Texas, wanting it to be a state issue, not something that was controlled by the federal government. And I think some realization that's been happening is that you can maintain mostly state control of this grid while adding much more substantial connections to the other two interconnects. In fact, we have projects being proposed now that would add 3 gigawatts of transmission east and another 3 gigawatts of transmission west. That's still small compared to the 80 plus gigawatts of peak demand that we have on summer heat waves, but it's much more than we have. And I've spoken with lawyers at FERC who say that there are just misconceptions to think that you can't have those connections and maintain state control. We can have those and still have a state-run grid. And I think, it's an open policy question. Have we benefited from this state control? We're a state that largely thrives on imports and exports. We buy and sell natural gas, oil, petroleum products, gasoline, jet fuel, every other fuel we trade across states and across countries. Why we've had this sort of xenophobia about our electricity has never really made sense to me. But I think if the desire is to keep it all within state, it can happen while still having better connections to the rest of the country.
Okay, Dan, last question. How optimistic are you about the ability to end, for the purpose of electrical power generation, not going to broader uses, our reliance on fossil fuels by 2035 or any other notional date future?
So President Biden set the 2035 target of 100% clean electricity. I'm doubtful and not optimistic that we will be 100% by 2035, but what matters is how close do we get? And I think we could have a grid that is more abundant, more reliable, more affordable than it is today, while getting in the ballpark of 90% clean electricity by 2035 and being on a pathway to get near 100% by the 2040s. And I'm not sure that 100% really should be the goal necessarily. There could be important roles that could be played by having a handful of gas plants be able to get us through the darkest and slowest wind times and not be purist about 100%. But if we can get to that 90% level, which we absolutely have the technologies, we absolutely have the capabilities to get there, to get to very, very high levels of renewable and nuclear electricity being the dominant sources of power on the grid, that's really the central pillar that I point to in my book, Confronting Climate Gridlock, about what's needed to move to a clean energy future, is that only if we can have cleaner, more affordable, more reliable, and more abundant electricity than we've ever had do we have a chance of using it to electrify our vehicles and our heating and our industry? Do we have a chance of using it to create hydrogen and fuels derived from hydrogen? Do we have a chance of having clean electricity power devices that suck carbon dioxide out of the air? So really, every other part of what's needed to confront climate change rests on the central pillar of being able to get it right and drastically move towards much cleaner, much more abundant electricity than we have today.
Great. Dan, thank you very much. And thank you all for listening. For more information, I encourage you to read Dan's brief on this topic in our Election 2024 Policy Playbook series. The link to the brief is available in our show notes. You can read other briefs in the Policy Playbook series at bakerinstitute.org/election-2024. Baker Briefing is brought to you by the Baker Institute for Public Policy, which provides meaningful, nonpartisan policy analysis on the most critical challenges facing the United States, Texas, and the world. This episode was produced by Karina Zamel and Gary Beaubien. AV production was led by Kevin Young. You can visit us at bakerinstitute.org to learn more. Thank you all.